Okay, on this problem, we're going to use the limit definition of derivative to find the slope of the tangent line to the curve f of x equals 4x squared at the specific value of x when x equals 2. So I've gone ahead and listed out our limit definition of derivative on the right-hand side, and the slope of the tangent line is equivalent to the derivative evaluated at that specific value of x. So here we have f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's jump right into it. I'm going to go and use x's as we go through, and then afterwards we'll put x equals 2 into our derivative function. You do have the option, you could replace each of the x's with 2 to begin with, but I prefer to do it this way. All right, so the derivative is going to be the limit as h approaches 0. And then let's work on filling in here. Okay, so initially what we want to do is we want to take our 4 and we need to replace the x with x plus h. All right, so x plus h is going to get plugged in where this x was in the original function. So x plus h is going to get squared. And then from there, what we want to do is we need to subtract the original function. All right, subtract f of x. So where we see the f of x in this formula, we're going to replace it with the right-hand side. So 4x squared. I didn't include a set of parentheses around this because it's a monomial, it's a single term. So I figured don't really need the parentheses around it. If, however, your original function had more than one term, you would want to include a set of parentheses because that subtraction needs to be applied to each and every term. All right, next, it's really a bunch of algebra and simplifying down as we go. We can't put 0 in for each of our h's exactly because our denominator would be 0. We're not allowed to divide by 0. All right, so the next step, what I'm going to suggest is a little bit of side work here. What we want to do is we want to think about this as 2 copies of x plus h multiplied together. Right, because that's what that exponent means is 2 copies multiplied together. So it is side work. Don't think of this as the equal to what we have written on the left-hand side. So as we multiply this out, we're going to go first, outer, inner, last. A lot of times this is called the distributive property. But first, we're going to get x times x. We'll make x squared, each of those first terms. Then the outer terms, we have x times h, we'll make xh. Plus the inner terms, we have h times x, but we can also think of that as xh. And then our last terms, we have h times h, will be h squared. Well, these middle terms can combine together if we want to. We can think of those as like terms. We have an xh plus another xh, so we have 2 xh's. All right, so back over to the left-hand side. We're looking at the limit as h approaches 0. We have 4 times, remember we just said multiplying out the x plus h squared works out to be x squared plus 2xh plus h squared. Then we'll bring along our minus 4x squared and the h from our denominator. All right, at this point, what I'm going to suggest is we're just working on expanding out our numerator. So we want to clear out that set of parentheses. We're going to take the 4 that's on the outside and we're going to distribute that to each one of these terms on the inside. So that's going to give us the limit as h approaches 0. And do copy that down each time. You don't want to lose easy points as you're working through this limit definition. So distributing the 4, that's going to make 4 times x squared is 4x squared. 4 times 2xh is going to make 8xh. And 4 times h squared is going to be plus 4h squared. Bring along our minus 4x squared from the end there, and it's still all over h. Okay, at this point, we want to think about, we've expanded out. Now let's think about simplifying our numerator. All right, so to simplify, we're looking for any like terms that can be combined together. And in this one, I think we have a positive 4x squared and a minus 4x squared that we can combine those together and make 0 x squareds. So what are we left with? What didn't get canceled out in the numerator? Well, we have 8xh plus 4h squared. Okay, we still can't replace each of our h's with 0, because if we did, it looks like we're going to get 0 over 0, and we don't want to end up there. So that's actually a good thing. And as you get going on these and you practice these, you're going to notice that at some point you want to get to the place where each one of those terms in the numerator has an h. All right, so we call that a common factor. We can remove that common factor of h. And I know they have 4's in common as well, but really we only care about the h, all right, because our end goal is to cancel out that h with the denominator that's only an h as well. So if we remove an h from the 8xh, we're going to be left with 8x. And if we remove an h from the plus 4h squared, we're going to have 4h remaining in there. And remember, if you redistributed that h to clear out your parentheses, we need to get the same two terms that we had in the numerator prior. All right, at this point, we're in a good place that we have the entire numerator is multiplied by an h, the entire denominator is multiplied by an h, so we can say h over h makes 1, so that can simplify. So where we're at this point is we still have the limit as h approaches 0. We're only left with that 8x plus 4h. And at this point, because the h is gone from the denominator, we can evaluate this limit by putting 0 in for our remaining h. So that's going to give us 8x plus 4 times 0, and 8x plus 0 is just 8x. Okay, so that's our derivative, f prime of x equals 8x. And it's a nice general form where we still have x involved, so we could evaluate this at any value of x we want to. However, let's be careful. On our problem, they want us to evaluate it at x equals 2. So what we're going to do is we're going to take this value of x, take it down to our derivative, and we're going to replace x with that value of 2. So in our case, we get 8 times 2 is going to be 16. So that means that that's our solution. That's the instantaneous rate of change evaluated at that value of x equals 2. All right, I did it with x's, but you could just as easily have done this with putting the 2 in at the very beginning. I want to point out that you could put a 2 in here and a 2 in here and work down. The algebra is basically the same in both of these. Some people just don't like seeing x's throughout the problem. X's and h's can be a little bit scary. That would have been perfectly fine in this case. I just chose to do it with x's, take my time, work every one of these steps as we went through it. So good luck as you're working on the limit definition of derivative.